Start streaming live from downtown Mill Bay. We are live from downtown Mill Bay. Please pull out your notes and turn to this page.
Wait, Mr. Newfeld, is there a test center tonight?
No, there is not. They canceled it. I had to come here and be the test center for my own grade 10 students who missed their quiz because they were too full. And they're also very, very strict. If you're not there at 7:30, even I can't get someone in. Like, I'll show up with a student, like, please, can they come in? Because then, no.
What's the point of being
They were not that strict last year. I was
No, they were
like
not.
750.
Last year, like most things, it's some people are the reason we can't have nice things. Last year, the amount of lates were so many and so irritating that, and it disturbs people come and go. They just decided this year, Ms. Allen was like, no, get everybody trained.
Okay, but what if you have a house meeting? What are you supposed to
You
do
do a
that?
test center at a different night.
There's no test centers.
Organize yourself, man.
Whoa,
Yeah.
aggressive.
Okay. We ended up with this. I'm not sure everybody did this as the last thing in their equation as they did. But we have a mixture of H and I. That's wrong. That should be H2 and I2 reacting at 448 degrees Celsius. When equilibrium is established, the concentration of the participants is found to be blah, 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 blah. Algebra review. What is mole L to the minus 1? What does that mean?
L over 1?
Sorry? Who said that?
L over 1?
L over, yeah. That's, sorry, not L over 1.
Mole L?
Mole over L. What is x to the minus 1? 1 over x. So if you see a unit, it's just because they didn't want to type it below and make a fraction. It still means moles per liter. So those are just all moles per liter. Do this. Write the balanced equation. Write the KQ formula. Put in the concentrations. Solve it. And probably make you do it at a board or something. Watch to see if I make any mistakes. You came very close to getting just a work block today and no quiz because I am quite ill. But I've had, estimating now, probably 6 shots of coffee. They didn't have a BFA show up and they didn't assign anybody, so Ron is covering Mr. Newfeld's class. Because the only good coverage for a Mr. Newfeld class is Mr. Newfeld. Pardon? Oh no, I made one. While you were in assembly.
So you weren't at assembly?
The ratio.
No, I was not. I had no plans of getting out of bed this morning. Oh, who just showed up? We've got Nicholas, and Evan still hasn't shown up.
Evan's at uni.
He's at what?
Uni tour.
Oh, jerk.
Oh yeah, you said you were. Okay.
Portia's here. Anybody else?
Shannon, why do you have 8 marks?
So
What? 5.
let's do that on the board. Grab a pen. Erase what's there. Erase the organic chemistry. B, you can go it alone, lone wolf it, or join any group you like. But I am feeling kind of spacey is the long answer to what I was just saying. So if I make a mistake on the board, call me out. I may make a few. Erase everything else there. Find a spot.
Write the KQ formula.
Sienna?
Yep.
You've done nothing wrong, but use square brackets. Just because it means concentration.
Are they all gases?
They are all gases. I should have said that, yes. Good point. You should get a really nice number.
Oh, I know.
Wait, are they gases?
They are all gases. I added in gas. And
Oh, maybe it's like.
Are you saying you should get a whole number?
you should get a whole number. I think I think it's set up that way. Let me quickly calculate it. But you do need the right equation.
That's not a nice number. That's wrong.
Because it's square, it has to be, or root 3. What? No, because you could square it, even if you just square the
Well, it should round to a nice whole number. How many sig figs do you need?
Oh, we need 2 sig figs.
Okay. Once you have your final answer, you can have a seat. 50.2. One.
We did round and brackets around 50. Oh, I guess we'll have to put it too. I want another banana, these are really yummy. Just open up the base. Why do you not open up the base? You always open up the base. Duh. You're like a banana. Ah. I don't want the gross top part.
I was wondering what you were doing. Got them. Oh, the back one, check your units. And for the rest of you, normally I would yell at you for, not really yell, of course, but I would say, where are your units for your final answer? However, KQ doesn't have any units. I mean, it does, but they change all the time, so we don't worry about them. In this particular case, if the KQ is equal to concentration of HI squared over the concentration of H2 times concentration of I2, if you just shoved into the units into that, what would happen to the units? They just totally, so it's unitless. Now, there are KQ equations where you essentially get x to the squared over x, depending on what concentrations on either side. So KQ can have units of moles per liter squared, inverse moles per liters, both of them to the -1 compared to where they are. And so it can be anything, so we ignore them. But I do suggest you put them into your work because we don't always give you moles per liter. Sometimes we give you like grams per milliliter and then you have to convert things. It reminds you to convert them. They do have to be in moles per liter when you put them in. And here's where I get to show you the flash animation. So exciting. Go. Where? Huh? Huh? Ooh. Yes. It's also slightly wrong. How many sig figs does that answer have? 1. How many should it have? 2. So how do we fix that?
Point.
Put a point, put a decimal there. It's just 50 decimal. Also, I understand what you mean, but don't do this. This is a math thing. And the reason it's a math thing is because in math you want to say, oh, it's kind of around this. Because math doesn't have significant figures. Because math deals with either precision or thereabouts. Whereas in science we deal with error, and so we know where our error lies, so we never really wanted to do approximately 2 as an answer. So I won't rewrite this on the board because we haven't, and it looks like everybody got it right. Any group didn't who wants to write it down?
It says at 448 degrees.
Yep.
How do you, like, does that, you just ignore that?
No, and in a lot of equations, it'll say at this temperature. What is the one factor we know that changes the KQ? Hmm? Not solid and liquid. I mean, those aren't included in the equation. But only temperature shifts change the actual KQ number, and now we're calculating the number. So they tell you a temperature to tell you that it's fixed. It's not going to change. If they said, here's the values at 20 degrees Celsius, and they said, and now we changed it to 30, that KQ wouldn't apply to the new one. It would change, and you might be able to calculate the change depending on what else they give you. But no other change will change it. So the only reason to tell you the temperature is to tell you that it is a fixed temperature. It doesn't do anything else. You have 2 more. Calculate those values. Shall we do it? There, new people. Find your new people. Once again, Portia, join any group you like or lone wolf it. And you have it right in your book. What time does this class end?
12:20.
Okay. Just do example 2, don't do example 3. I want to do one more thing before the quiz.
Look at us. We don't know what we're doing. Actually, I don't know. No, not to you.
There's brushes. Don't use your nice sweater to write and do things off, and don't use your hand. Those of you using, we have brushes. Brushes. Hey, Margaret.
Whatever you say, Candace.
This stream and then
Why?
because there's 2.
And we usually all parts of the day.
Huh? Yeah, at the bottom. Okay, with the. Let me tell you the numbers. And then now you have to if you watch it, so n value is 20, you can do the rest of 2 whole. Like, do you want me to do it? Don't say that. Like, tell me. Choose. NHP is 23 moles. I already opened it. Okay, no.
Actually, don't know what the answer is.
Yeah, do you want to get
Page 2.
calculators and stuff?
Yes.
That one. And then NH3 is
Or something.
or.
5,
Ooh, nice.
0. Here's 2 zeros. 5, 4.
I think everybody has the equation. Yeah, I do.
Marcus, it's 0.3 cubed. 0.3 cubed.
What?
0.3 cubed, not 0.6.
Sig figs. That's 2 sig figs. That's 2 sig figs.
Wait.
Yeah, okay, yeah. And then all the variables are cancel each other out. Technically, so we don't really have to write it. Oh wait, there's another one. Okay, are we doing both of them or just? Are we doing both?
Nope, just the one. What did everybody get?
11.
Woo, nice. Because I also got 11. I lost my sheet.
I think it looks like her.
We converted from large feet to large arms. 11,
It
11,
looks like her.
10.6,
She looks
15,
so
11,
happy.
She does look very happy.
11, 11. Do pay attention to sig figs, but also don't panic about them. These are all 2 sig figs. But the reason you don't have to panic is because traditionally in grade 12, what we do is we pick one random question, and that's the sig fig question. You get the sig figs wrong, it's a tiny little half a mark equivalent off. If you have it right, then you got it right. It's often a log question because the sig figs for logarithms are different than everything else you've learned so far, but we won't do that until a little bit later.
Wait, Mr. Nicole?
Yep.
For the cross grade, is Mr. Snow marking it?
Oh, no, we mark our own classes, but we're all making the test. So it turns out he gives, for example, tests that are quite a bit shorter than ours.
Yeah.
So we've come to a compromise. So it'll probably be a little bit larger than what he gives. It'll probably have, from your experience, a little bit more long answer, a little shorter multiple choice. I'm going to make up a version and show it to him, and then we'll know those details there. Okay, we're not going to do that one. If you've done the quiz that we're about to do, go back to that. But we're going to do this. And unfortunately, do your notes have this in it? Like this thing?
Yeah.
I meant to blank those all out, and I think I forgot. So you are expected to make this. We're going to do the same equation. Find nitrogen gas and hydrogen gas react to form ammonia. And so you do the same thing. N2 plus H2 goes to NH3. And then it's the same equation we just did, so we balance. But the N2 was an do we have, could you calculate from this the KQ like you did in the last one? What's wrong with those values? I will highlight the important words. Pardon? Only gives you one value at equilibrium. You need equilibrium values to calculate the KQ at equilibrium. What we have are the initial values. We actually have the initial values for all three, even though it only tells you two. N2, now this is the world's greatest table. It has its own song. I stands for initial. C stands for change. And E stands for equilibrium. So it's an ice table. So we take the initial value, pop it in because it's initial, 0.32 molar, and the H2, also initial, pop it in, 0.66 molar. I'll switch colors because now we have an equilibrium value for H2, which is 0.3 molar. And we pop that in, but I won't cover it all up. 0.30 molar. What is the value? Well, we're missing an initial value, except I've said we know it. Nitrogen gas and hydrogen gas react to form ammonia. The concentration of N2 initially was this, and the H2 initially was this. What was the initial concentration of ammonia? That which is not done is often unseen.
So we have to calculate it.
Nope. You're a chemist, and you've set up this reaction. What are these? Like standard grade 10 question. What are the things on this side called?
Reactant.
Reactants. You're trying to make that. How much product do you start a reaction with? Zero. So this is the meditation amount. You don't mention what you didn't add. It's like all the students in the house yesterday who were confused because I texted every student in the house saying, please check to make sure your van is correct, and that if you ordered a van, there is one there. Because I know who is on the leave list, but I don't know the name that wasn't added because it wasn't added because it's not there. So I have to ask everybody. We never say that nothing was added for the products, and so you just assume it. If they said we're starting a reaction and we started it with these values, then what they essentially said is that we didn't add this. So that one you do know. We also know we can calculate one other value very quickly. The change. How much did this change? 0.3. Positive or negative? Did it minus or did it add?
I think it did it add.
How did we get from 0.66 to 0.30?
Oh, we minus.
We minused 0.3?
6.
0.36. 4? It's okay.
Are we rounding?
Rounding? There's no rounding in here yet. Which area did you mean rounding?
Never mind.
Okay. Now, equilibrium doesn't have to be even on each side. It could be anything, as we know. The concentrations don't have to correspond. But what the stoichiometry that does happen happens in the change. Because if this went down by 0.36, how much did that go down?
6.
Well, not exactly 0.136. Don't forget,
Oh.
they have coefficients.
2.
So
5.
0. And did it add or subtract? Subtract. So this I should put this in like, I've already used red. Let's do a nice fall color. This is the stoic row. I thought it ended, what?
It's just fell from the normal day.
Okay,
Yeah, class one.
stop that. So,
It's over.
stop that. I may have had a fever, and I am incredibly spacey, but I'm pretty sure class isn't over. And I have a, it's not over. If these went down, what happened to the other side?
Divided by, or it goes up by 2.
Goes up by 2. So what should this one be?
2.
2? 0?
It's 2.
No, well, we know how those change. How did this one change?
Wait, 0.24.
0.24? Did this side go down?
No, went up.
Went up. Because if these are reacting to make, and that makes sense. If it's an equilibrium and there's nothing on that side, it's gonna. Which way is it gonna shift if all the concentration's on that side? This way. So it makes sense if that goes up.
Which one do you use?
What about the H2?
Which one do you use?
Oh, it's
Either one, you'll get the same
What?
answer. You'll get the same answer.
Yes. Are you asking how we got that?
No, I'm asking.
Oh, it's divided by 3.
I'm asking.
You get the same
Like,
Do you play the music?
how do you go from the reactant side to the product side? Like, how do you get that number?
This number?
Yeah.
So the change has to go through the stoichiometry. So we know, because we were given in the question these two values, so we know that this went down by 0.36.
So it's like the difference between the N2 and the H2.
Yeah, so this is the difference. And then if that went down by that, then divide by 3, multiply by 1. This had to have gone down, because this only goes down if it reacts with this one. If these both went down by that amount, then that divided by 3 times 2, or this divided by 1 times 2, gives you the amount of that they made. Stop that. Math isn't real. Chemistry's real.
Wait.
Can you play the music?
Wait. So, basically,
Oh, units, same as in here. They're all M. Because it started off as M, that's M, they're all moles per liter.
so
Go.
what value do you use to get the product?
You're using the stoichiometry.
Do you remember when you go,
Okay,
you divide by,
yes,
you divide
Yep.
by 3 and then go
What
times
happens
by
if
2?
you just use the N2, which you did,
Yeah,
right?
yeah.
What happens to the 3H2? There shouldn't it be 0.24 plus 0.36 divided by 3 times 2?
No.
No.
It's
No, stop. No, stop. Forget these numbers.
Okay,
If I have one atom of this,
yeah,
and I react it with 3 atoms of that, 3 molecules,
yeah,
how many atoms of that do I make?
2.
2. How'd you get 2?
Because it's balanced.
Because it's balanced.
Yeah.
And so this is balanced in a 1-3-2 ratio, right?
Yeah.
So when we know this we divided by 3 to get this into a 1-3 ratio.
Okay.
And then we just
Okay, yeah.
took that, so it's now in a 1, so we just balanced it.
Okay.
That make sense?
Yeah.
For stoic, can't you usually only divide by 3, whatever, to get that? Can't you only do it with moles?
Oh, no, you can do it in concentration too. In grade 11, you can only do it with moles, but our liters aren't changing. So you can do it here. If the volume was changing, then you couldn't, but if the volume was changing, then the equilibrium would change anyway, so. You can also do it with pure volume for liters of a gas, but
so
that's,
you can only do it with concentration when it's
you can
at
do it with concentration.
equilibrium?
You can do anything that's related to the number of
No, but
atoms.
like only when it's at equilibrium.
Only when it's at, no, as long as the volume's not changing, you can do it. And that's what, those are the units you'll be using all the time. Now, you can calculate the equilibrium volume for all of them. What is it for N2?
0.2.
Moles per liter. And what is it for NH3?
0.24.
0.24. Now calculate the KQ. Because this is our initial, it went up, and then it went to that. This is our initial, it went down, and then it's that. This is our initial, it went down by that amount, and now we have that.
So when we calculate K and Q, do we still use, wait, can you scroll up?
Mhm.
Do we still use like the front number as like the power?
Yes.
Okay.
So, and, I mean, we've already written this, so I'll use up there. Please, when you write the KQ, I've noticed is there a tendency to want to like cut to the answer, and people will start putting in numbers right away. Please write this equation. This, even if you get everything else wrong, but you write this equation, I mean, that's a developing low, or at least 1 mark out of 5, or whatever this is, because you've shown me you can at least do the KQ. But if you just put in numbers, and the numbers are wrong, and the other things I can't tell if you know the KQ equation, then it's hard for me to judge whether or not you know it. And this really clears out and communicates your work, because now you can pop it in. What's the value for NH3?
0.24.
0.24. And what mathematical operation do we do with that? We square it. And we divide it by
0.2.
0.2. And also divide it by?
0.3.
Oh, because this says concentration of this. But that is a concentration. So now I'm just showing the mathematical operation.
Would it be okay?
You can
if I did
keep
square
you can
brackets?
keep them square if you'd like to. It's not wrong.
0.3 cubed.
2?
Cubed.
Cubed. Perfect. And then if you calculate that, what do you get?
11.
You get 11.
What?
What does?
Because does the KQ change?
Why did I get this wrong? Why did I get it wrong?
Wait, but why is it more?
It's the same thing we did on the board, Marcus.
No.
How the fuck's I get it wrong?
What is the unit of big M?
Molar.
Nope. Moles per
Oh,
liter.
it's 20, it's not 10.
There is no shortened version of the shortened version of
So
mole.
are you taking the equilibrium?
Moles. So who said that?
Me.
Yes. So the equilibrium values.
Oh, okay.
So the point 24 went there. The point 2
But why
went
did
there.
you do the beginning ones?
Pardon?
Yeah, because you do the
Like, why couldn't you do like the beginning or the middle values of the table?
Because you have to calculate it
Equilibrium. The KEQ only works with equilibrium values.
I thought we did it with constants or concentration before.
Yes.
Oh.
that's
Concentration at equilibrium.
Oh.
Because now that it's settled out, these values don't change, but those values are changing.
Is it always going to be concentration at equilibrium?
Usually. Sometimes they'll say all these concentrations are in a 2-liter container and then turn it into concentration.
But isn't concentration? I thought concentration wasn't affected by.
Yes, it is. Because if
Wait, but like you said, no.
the concentration doesn't affect the KEQ value. So what did we calculate here at KEQ to be? 11. And with, are those the same numbers actually? Did I do that? Oh, I even made it the same numbers. If at that temperature I used completely different values, like I could change all of these. I could make this 0.1 and I could make that 0.7, or let's go 50.3. We could do a change and the answer will still come out to 11.
How does temperature come into play then?
That's what I was going to ask. Because if it's at like, if it's an exothermic or endothermic, does it change?
So temperature is the only thing that will change the KEQ value itself.
Yeah, but how does it change the KEQ value itself?
Oh.
Like how does it come into the equation?
So, it doesn't go in the equation. You
So
just
then-
have to get the values and calculate a new number for that temperature.
So how do you?
So are you asking why did they give you the, like in this one, why did they give you the temperature?
Yeah.
It doesn't appear in any equation. That just tells you the temperature is fixed.
Okay.
It's a
And so
temperature.
if it's not fixed, then
Then you wouldn't be able to calculate it.
But what's the point of even doing this?
Honestly, well, on a short-term level, to pass chemistry 12.
Like, on a big
But on a
level.
long-term level, you can then calculate if I put in these amounts, how much product am I going to get?
So it's like.
Like you can calculate the amount of product or reactant that you need.
But can you just do that with algebra?
Well, you needed algebra to solve that. That is the algebra.
So all the ones that we did before, these ones were all at equilibrium.
At equilibrium, and
And
they
so
all, now this is the first one wasn't at equilibrium. You have to calculate what they are at equilibrium.
Okay.
There's one in the Hebden book that was like, it was, I can't remember, but it was something to the power of like 1/4. How, is that just the same? Like, how do you calculate that?
Let me go back and do it. But technically speaking, you could say that all of this is 1/3, 1, 2/3. Is that still balanced? And if you make a KQ equation of that, you will get a constant number that you can use with that equation that will always work.
Will that product be 11 then?
To be honest, I have to double check. I think it is, or you have to always use that balancing, and then you get consistency. But you'll always get the same number. But you can balance it differently, and then calculate a KQ. It's still balanced.
In the Hebden, it was saying to, it was like balance not balance, but reconfigure the equation, like the KQ equation, to make it like equal.
The reason they were doing that is because they want us. The other thing we can do is we can give you this, and I can give you that and that. And I can say, what is the value of NH3? So then you just go, well, NH3 is equal to KQ times N2 times H2 cubed, and it's squared, so we'd have to take the square root.
What is,
So it's just a quick way to algebraically, how do you calculate that?
Okay.
Could you pop in all the numbers and then solve? Yes. But it's just to get you back into the feeling of algebra.
what if you have all of the values like on like the equilibrium values, but nothing on the top,
Nothing on the,
like nothing in the initial rotation?
What, or yeah, like what if
Yeah.
one of them, what if one of your reactants is like a solid or a liquid, so that you, like,
Yeah.
the, so what if one of your
you don't put it
things-
in.
But would you, like, so if,
You then, the concentration never changes. You don't need to worry about its
can we do another practice one?
I think I'm going to give you your quiz now.
Wait, no, but
Because you asked so many questions.
Wait, I have one more question.
Put everything away, get all your thing,
Wait,
start
we
as soon as
don't
you get it.
have
Go,
enough
go, go,
We
go,
don't have
go.
enough time.
Yeah, you
There's
do.
8 minutes left of
That's
class.
okay. It'll be 4 minutes. Go, 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 go.
wait, this
Yeah, I can tell when you're going.
I have one
Do you think
class.
No more questions.
do you think you're this class?
Stop it. I can tell when you're all of a
Back
sudden.
to equilibrium.
Go, 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 go.
How are we supposed to do it in 7 minutes?
Quickly.
Not enough time.
That's okay. 4 minutes.
Oh my
Do we
God.
have those little bubble sheets to fill
Yeah, but you just start working.
Guys, if we all get up and leave, we don't have to.
I will breathe on you and give you a fever. Yeah. No, don't use your notes. Just, you want to see how well you do. And if you could separate a little bit, you're a little close together.